Hi, and this is lesson 3-2. You should be on page number 141 right now. Actually, I guess you could go right to 144. There isn't any vocabulary in this lesson. We're going to be solving two-step problems today. I'll just write that down. We're on page 144. All right? We're going to get right into solving problems. And again, as I solve these, I'm going to consistently refer to the onion, just like I talked about in lesson 3-1. I think that's a great way of solving an equation. Onion, we have to peel each outside layer to get to the inside. We got to peel away one layer at a time. So when you go to a problem like number 6 on page 144, 2g minus 13 equals 3. Step 1, remember, write the problem. Step 2, let's try to simplify. Well, I can't simplify 3. And 2g minus 13, I can't combine those together. They're not alike, okay? So let's think about my onion for a minute. The variable is the center of the onion. The next layer would be the times 2 right next to g, and then the outside layer that I'm looking at would be the minus 13. I have to get rid of this outside layer. I got to get rid of minus 13 first. Well, remember, the inverse operation of minus 13 would be to add 13. So let me erase my layers here. I think you have a picture of what the onion looks like. So to get rid of the outside layer, I got to get rid of minus 13. So let's add 13 to each side. That's the next step. And when I add 13 to each side, I'm going to get, these cancel out. I'm going to get 2g on the left. 3 plus 13 is 16 on the right. So my step 3, the step 3 that I just did the addition property of equality, and I simplified. Okay? Now, think about the onion again. G is the center. The very next layer is that times 2. How do I get rid of times 2? Well, I got to do the inverse. I got to divide by 2, so I'll do that next. 2 divided by 2 is 1. I get 1g on the left, and I get 8 on the right. So my next step, my step 4, was I used the division property of equality. And I simplified again, and I have g equals 8. And then remember, step 5 would be to check my answer. So let's check it. Now g equals 8. Let's check if 8 works up in this equation. 2 times 8 is 16, and 16 minus 13 equals 3. So yeah, those check. And remember how we talked about equivalent equations. If we're doing our proper work, all my equations should be equivalent. So let's just see if that's true. If I put an 8 in for g, 8 does equal 8. That's true. 2 times 8 would give me 16. That's true. And 2 times 8, which is 16 minus 13, gives me 3. Do you notice how all my equations are equivalent? If I'm doing the proper work, each step will be equivalent. Okay? So on paper, when you turn in your homework for something like this or take a quiz, what I would want to see, remember, I want to see your work in this way. I would want to see that, write the equation. You're adding 13 to each side. You have 2g equals 16. And we're dividing each side by 2, and g equals 8. That's what I would want to see on paper. That's what any of your teachers, I think, going forward would want to see. That makes sense to any of your teachers teaching, like I said, Mr. Keller, Mrs. Bossack, Mrs. Bassett, Mr. Baker. Any of them would look at that and be like, I think they'd say that's exactly what I want to see for solving an equation. Okay? Let's go to number 10. So I wrote the problem down. 17 equals w over 5 plus 13. And let me just think about my onion real quick. W is the center of my onion. So w is the center. Divide by 5 is the next layer, plus 13 is the outside layer. I have to get rid of plus 13 first. I got to go from outside to inside. So to get rid of plus 13, the inverse of adding 13 obviously would be to subtract 13 from each side. And I forgot to say something. I forgot to remind you, step 2, remember, we should always try to simplify. Let me try to do that before I continue here, because I should always remind you of that. I can't add W over 5 plus 13 and 17. So, okay, I tried to simplify. I can't. So now I can go and start peeling away my onion. That outside layer was plus 13. So I'm going to subtract 13 from each side. And I get W over 5 on the left, because 13 minus 13 is 0. And on the right side, I meant to say, W over 5 on the right side. On the left side, 17 minus 13 is 4. Okay? So step 3, I just used the subtraction property of equality. Okay? And I simplified. So now I have 4 equals W over 5. So think about your onion. W is the center. The next layer is a divide by 5. To get rid of divide by 5, I need to multiply each side by 5. Divide by 5 times 5 cancel out, and I have W on the right. 4 times 5 is 20 on the left, and I just used the multiplication property of equality. And maybe this would be a good point just to say, remember how the title of this lesson is two-step equations? Okay, there's my 2 steps. I used the subtraction property of equality for 1 step, and I did the multiplication property of equality for 2 steps. Okay, so I'm getting W equals 20. So when I'm done with that, remember step 5, we should always just double check, is my answer right? So I'll plug 20 up here. 20 divided by 5 is 4, and 4 plus 13 is 17. So this equation is equivalent to that, because if I put 20 in here, 20 does equal 20. And remember, this equation should be equivalent also. 20 divided by 5 does give me 4. So since my work's right, all my equations are equivalent. If you jump ahead to 24, this is one of the things on my I can list. My I can list, one of my I cans is I can find the input of a function given the output and the verbal rule. So number 24 would be an example of that. They want me to write an equation for the function described, then find the input. So if you look at 24, it says the output of a function is 7 more than 3 times the input. So the output is y. The output is means equals 7 more than, I'm adding 7 onto something, 7 more than 3 times the input. And remember, the input's x. Remember back in chapter 1 when we did our tables? When we worked our tables, this was the input, y was the output. So when it says output in the directions, that's like having y, and when it says input, that's like having x, okay? So I wrote an equation. Now, here's the next part. Find the input, so find x, when the output is negative 8. So I want to replace y, which is the output, with negative 8, and that equals 3x plus 7. Okay? So I'm not going to write down all this again, but I think I've done it enough on my video, so let's think about each step. Step 1, write the problem. I did. Step 2, let's try to simplify. Well, I can't simplify negative 8. Can I add 3x and 7? No, I can't. I tried to simplify. I can't. Think about your onion. Here's the center layer. Here's the next layer. Times 3 is the next layer. The outside layer of the onion is plus 7. I got to get rid of plus 7 first. So let me undraw my onion. So you can see I got to get rid of plus 7 first. Then I got to get rid of the times 3 to get to the middle of the onion, the center of it. So let's get rid of plus 7. Well, I'm going to use the subtraction property of equality. I'll subtract 7. I get 3x on the right. Negative 8 minus 7 is negative 15 on the left. I'll now use the division property of equality to get rid of the times 3. I got to divide by 3 to get rid of times 3. I get x on the right. I get negative 5 on the left. Let me check it. I think my answer is supposed to be negative 5. Let's see if that works. So if I go up here and put a negative 5 in for x, 3 times negative 5 is negative 15, and negative 15 plus 7 does give me negative 8. This equation is equivalent to this one. Let's see if this is equivalent. Is 3 times negative 5 negative 15? Yes, it is. All my equations are equivalent because I did my work correctly. Let's go to 16. So let's write the problem down. Now remember, the next thing I always told you to do is see if you can simplify. Here's why, because this is a classic example. If you look, this is the first time. Yeah, I can. 2p plus 7p, I can combine and make it 9p. So I definitely always want to try to simplify first. And here's the neat thing, if you catch that, because you simplified, this is now an easy one-step problem. Center of the onion's p, the next layer's times 9. I got to get rid of times 9. So how do I get rid of times 9? I have to divide by 9. So I just use the division property of equality. The 9's cancel. 54 divided by 9 is 6. Now let's check. P is 6. Let's go back to my original equation. I plug in a 6 here and a 6 here. 2 times 6 gives me 12. 7 times 6 is 42. 12 plus 42 does give me 54. It checks there. And if I go to this equation, 9 times 6 is 54. Do you notice I have all equivalent equations? I'm doing my work right. One last question that can mix people up, so I definitely want to go over this situation. If you look at number 30 on page 145, want to solve this. Step 1, write the problem down. Step 2, let's see if we can simplify. Well, negative 8, can't simplify that, and I can't take 16 minus 2.4d, they're not alike, so I tried. This problem worries me a little bit, and here's why. Center of the onion's d. The next layer, we're multiplying d by negative 2.4. Here's the outside layer. Here's what worries me. We got to get rid of the 16, but what do we have to do to get rid of the 16? Well, this is what I see a lot of people do. They see a minus sign here, and they want to add 16. But wait a minute. Think carefully from what we talked about back in Chapter 2. Does the minus sign apply to the 16? And the answer is no, it doesn't. It applies to the 2.4. Look at 16. The sign in front of it right now would have to be a plus. I got to get rid of plus 16. So to get rid of the outside layer of the onion, I got to get rid of plus 16, which means I have to subtract 16. So let me erase my onion, and let's solve this now. My outside layer is this addition, or this add 16. I got to subtract 16. I'm using the subtraction property of equality. 16 minus 16 cancels out. Now be careful, the minus sign in front of the 2.4d didn't go away, it's still there. I got negative 2.4d equals negative 24. Okay, now think about the onion again. I'm multiplying d by negative 2.4. So to get rid of this layer of the onion, I'm going to have to divide by negative 2.4. That's the inverse of multiplying by negative 2.4. So I'm going to use the division property of equality and divide by negative 2.4 on each side. And negative 24 divided by negative 2.4, if I'm doing that in my head right, that's positive 10. I should check my answer now. D is 10. Let's go up here and check it. If I plug a 10 in here, 2.4 times 10 is 24. 16 minus 24 does give me negative 8. So remember, these are equivalent equations. If I've done my work right, they ought to be. And even this one is equivalent because negative 2.4 times 10 is negative 24. So there is the video for this lesson 3.2, and I'll let you ask questions when you come in class, or if you have, when we get started on the homework, you can ask questions at that time too, if you have more.